Hello students, right here again today. Today we're going to look at practice problems 10.3.3. Where we're looking at numbers 42 through 46 on page 339. Probably won't get all these done today, but at least get a couple of them done, and then we'll finish up the other ones next time. Number 42. We have 45.6 grams of ethanol, C2H5OH. And we want to figure out how many carbon atoms, how many hydrogen atoms, and how many oxygen atoms are present. So, first thing we got to do is find the molar mass. So we look up carbon, hydrogen, and oxygen in the periodic table, find their molar masses. Carbon is 12.01. Hydrogen is 1.008. And oxygen 16.00. Your periodic table may have slightly different numbers. If it does, go ahead and use those numbers. It will still work out. Then we multiply by how many we had. Carbon, we got 2. Hydrogen, there is 6, because we got 5 there and 1 more over here. So there's 6. And oxygen, there's only 1 of them there. So then we do some multiplying and some adding. Take out your calculator, and you do 12.01 times 2. Always make sure you do the calculations as we're going through these. So 12.01 times 2 plus 1.008 times 6 plus 16, and we get 46 point, and I'm just going to round it to 0.07. Grams per mole. So that we have that, we can go back and find number of atoms of the carbon, hydrogen, oxygen. I find it easiest always if you have one of them there only once, like the oxygen is here, I'll start with that one. So we take 45.6 grams of the ethanol, C2H5OH. And change from grams to moles. So we just figured out there's 46.07 grams of the ethanol, C2H5OH, and 1 mole of the ethanol, C2H5OH. Grams, divide out to grams. Then, if you're changing from the grams to the moles. Now we're going to switch substances. So in 1 mole of the ethanol, there is 1 mole of oxygen atoms. And the mole cancels the mole. I'm running out of room, so I'll come down here. And we switch from 1 mole of oxygen atoms has 6.022, Avogadro's number, times 10 to the 23rd oxygen atoms. And the moles cancel the moles. So, yeah, basic procedure on problems like this. Change your grams into moles, switch to substances, and then use Avogadro's number. And take out your calculator. You will multiply and dividing 45.6 divided by 46.07 and times 6.022 times 10 to the 23rd. And we find that we have 5.96 times 10 to the 23rd oxygen atoms. Yeah, that's actually our answer to part C. Yeah, to do the other 2 parts, they end up being pretty simple. We're just going to go to carbon atoms now. So for carbon atoms, instead of 1, we got 2 carbon atoms. So the first part of the problem stays the same. But instead of, when we get down to this part right here, instead of in 1 mole of methanol we have 1 mole of oxygen atoms, we have 2 moles of carbon atoms. And in 1 mole of carbon atoms there is 6.022 times 10 to the 23rd carbon atoms. So all we really changed is that 1 to 2, so we just need to take this preceding answer we had times 2. So if you still have it on your calculator, all you got to do is hit times 2. And we get 1.19 times 10 to the 24th carbon atoms. If you didn't have it on your calculator, you just retype it in. And then for the hydrogen, we get 6 of those. So, much like before, this becomes a 6 now. Switch colors, this becomes a 6 now. And hydrogen atoms, and this becomes hydrogen, this becomes hydrogen. So we could take that first answer times 6, but if you still have that second answer you have on your calculator, you can use that and just multiply it by 3, because we'd already multiplied by 2, and times 3 gets us to 6. So I'm going to take, I still have it on the calculator, so I'm just going to take that answer times 3. If you didn't, you could go back to the first answer and take it times 6, and we get 3.58 times 10 to the 24th hydrogen atoms. So, basic procedure we need to go through. Now we move to problem number 43. Number 43, we have 2.25 grams of sodium sulfite and we want to find out how many sodium ions, how many sulfide ions, and then we want to find the mass of one formula unit. Again, we start by finding the molar mass. So molar mass, we got sodium, sulfur, oxygen. Sodium, there is, look them up in the periodic table. And we find sodium to be 22.99. Sulfur is 32.07. Good practice. Look these up on your periodic table as well. Again, if you, like before, if you have different answers or different numbers given to you, you can use the different numbers. They should be about the same, just rounded in a different place. And oxygen 16.00. When you get done, you should end up with the same answers. Your answers may be slightly different in the last significant digit. That's estimated, so it can be off by just a bit. Sodiums from our formula, we got 2. Sulfur, we have 1, and oxygen, we have 3. And we run through our calculator, do the 22.99 times 2 plus 32.07 times 1. Don't have to type times 1 in, plus 16.00 times 3. And we get 126.05 grams per mole. So that's our molar mass. And we use that to do the calculations. So we start with the 2.25 grams of sodium sulfite. And just like before, we're going to change that first to moles. So we figured out there was 126.05 grams of sodium sulfite. I wrote a 4 over here. Now it's supposed to be a 3. In 1 mole of sodium sulfite. Grams, cancel the grams. Then next, we now take and switch substances. So in 1 mole of sodium sulfite, we look back up here. We wanted to get sodium ions. There is 2 sodium ions, and for every 1 sulfite ion. So I'm going to start with the sulfite because it's the 1. I like to start with 1 here. 1 mole of sulfite ions. Just notice I wrote a 4 there instead of a 3. It's supposed to be a 3. And moles, cancel, moles of sodium sulfite. Now, again, I'm running out of room up there, so I'm going to bring it down here. In 1 mole of sulfite ions, there are 6.022 times 10 to the 23rd sulfite ions. So, same procedure we did on the preceding problem. Change from grams to moles, switch substances, then use Avogadro number to find a number of particles. Moles of sulfite ions, cancel moles of sulfite ions, and we're ready for calculations. So we got 2.25 divided by 126.05 times 6.022 times 10 to the 23rd, and we get 1.07 times 10 to the 22nd sulfite ions. This one I'm very likely, because with all that I got 1.0749. So if you had a little different numbers off the start, you might end up with 1.08 times 10 to the 22nd. That would be okay. My answer key actually has 1.08. Then, for our sodium ions, all we need to do is, we're supposed to have 2, so this becomes a 2, and 2 moles of sodium ions, and all the original part stays the same, and this becomes sodium, and this becomes sodium. So all we have to do, if you still have it on your calculator, if not, you re-enter it, but take the 1.07 times 2. And we get 2.15 times 10 to the 22nd sodium ions. Again, might have got like a 2.16. That would be okay. And last, we need to figure out grams in a formula unit. Here, all we need is some molar mass and the Avogadro's number. So, molar mass, we know there is 126.05 grams of sodium sulfite in 1 mole. And then we know there is, in 1 mole, there is 6.022 times 10 to the 23rd formula units. And the moles, cancel the moles. And all we got to do is take 126.05 divided by 6.022 times 10 to the 23rd. As always, do the calculations. Type them in your calculator. Make sure you understand how to do that. And we'll do all that division, and we get 2.09 times 10 to the negative 22nd. Grams per formula unit. Now, that's as far as we're going to get today. The next time we will be looking at, we'll continue on with this little group of problems. Next time we will continue on with this little group of problems, and we'll be looking at numbers 44, maybe we'll get all the way through 46. So we'll continue with those problems next time as we do practice problems 10.3.4. So that will be what we get next time. Now, if you want to, go ahead and try these problems. And then you can just use my video to check your answers. If you're still a little uncertain what you're doing, I'll be showing you how to do them next time. So that's all for now. Till next time, strike.